Okay, last week we already cover a little bit on our chapter 2, but there are still many others to cover. So I hope that maybe today we're going to speed up a little bit. We are finished until here already, our first complement to complement. I just want to do some recap or review back on what we have learned. So is it okay if I speed up, because I think we need to finish our chapter 2 by this week. Next week we're going to start with our lab. So in our first complement, we already looked into, which is we just convert it if it is from 1 and it's going to be 0. From 0 it's going to be 1. Same goes to the step on 2's complement. So for 2's complement, you need to have 2 steps. First step, where is it? Okay, 2's complement, you can see that it's nothing more than first complement. 2's complement, dia lebih kurang dengan first complement, but what is the difference is you need to increase it by 1. So first you're going to flip, which is if let's say it's 0, you're going to change it to 1. If 1, you're going to change it to 0. This is first complement. Then for second complement, you need to add with 1. So you need to add 1. If you have a number, let's say 1001, so you need to add with 1. This is your first complement. I just give you example. I pick random number. So it's going to be 1010. So this is your second complement. So this is how you convert from your decimal number, going to convert to your first complement, and then you're going to convert another step, which is add 1 to be second complement. So normally if you are having negative numbers, please use second complement to do the adding, to do the subtraction, but basically subscribe the negative number is going to be adding process for 2's complement. So this one, I guess you already tried it and we already looked into. And about detecting overflow, we already stopped until here today. So there is 2 conditions only to have overflow. First is 2 positive number added, and then positive tambah positive, suddenly you get negative result. So it's called as you having overflow. Another situation, when you have 2 negative numbers, you add them together, but your result suddenly to be positive. So you name it as overflow. And normally if you use 2 complement, it is not possible to have overflow, although you are using 2's complement. If a positive and negative number being added together. So over here you were given the overview why basically it's going to be overflow. First, you can see over here, if the carry, this one is your carry for your last bit, into your sign bit 1, 2, 3, 4, 5, 6, 7, 8. So it's already 8 bit over here. So we already learned that the left numbers, which is our MSB, going to be the sign bit, right? If 0 is going to be positive number. If 1 is going to be negative, isn't it? So from here, if you look one by one, you can see that over here, your carry 1 plus 0, you get 1. 1 plus 1, you get 1, 0. So your sum will be 0. Your carry, you will be using this, right? So this one is 1, meaning your carry. So carry over here, if you look what happened, you can see your sign bit equal to the carry out of the bit. So there is no overflow. This one and this one is similar. So you assume your answer will be correct because there is no overflow. But the second scenario, if your carry into the sign bit, this one is your sign bit, out of the sign bit a different. So you tengok sini, this one and this one tak sama. So its difference means that it's having overflow. So you dapat dekat sini it is negative number, but suppose you will get positive, right? So this is overflow situation happen, or overflow condition. But basically it's happen if you are dealing with, this one is already more than 8 bits, then you can see that this charge is more than the sign bits over here. So later on you will see also the example, and I ask you to look into one by one. So only one person asking me question basically about, I guess, this one. The student asking me whether this one is already second complement or not. So I mentioned this one is just a number. So he need to change it in using two complements. I also basically not yet try this, but this is just to test you to understand on how you're going to do your numbering, which is it already give you over here base 2 mean binary number. This one there is no base at all. I guess it is already choose complement. So you can see the difference. So if you still have difficulty or you did not understand or you cannot do the question, please WhatsApp me and ask me directly. It's okay? So we're going to make it a little bit faster. We're going to try to finish. You can see that you're going to learn on negation, addition, subtractions, multiplication and division. Dah macam matematik pula kan?
Doctor, sorry. Just now, when you said that, can you repeat what you said regarding if it's already second complement or not? So this one is already in second complement, correct?
Which one?
This one, the 2.5.
2.5. I guess this one is not yet second complement. This one is binary sign.
Oh, so if it's binary, then it's not. Then you have to convert it first.
Yeah.
Okay. Right, got it. Thank you.
I guess this one is just a review question, which is want to test you. Wait, I need to close the door. Wait. Okay. And normally in test or quiz, it's not going to be confused. Something like this, right? It's quite confused, right? Whether this is already to complement or first complement. Basically, it's going to be very detailed in question, whether this one is binary or first complement or second complement. Then you've been asked to use what complements or what's methods for you to adding or subsetting. So it's not going to be a question that very loose which is not very strength in the question. It's going to make you confused. So don't worry about your test, which is you're going to get a very detailed question. I need to. My name is Kyrene. I'm sorry that I can't join your class. Okay. I need to accept first. There is someone want to join. Dia, Dia, you just come in. Okay, we continue. Okay, first of all, we're going to look into the negations. So in this section under negation, you're going to see as exercise commonly with under arithmetic function for your two's complement representation. In two complements notation, the negations of integer can be formed. There is two. First, take the Boolean complements of each bits of integer, including the sign, set each to 1 to 0, and each 0 to 1. This one is the one that I give you the example, which is if you have the number 101, then you need to do the first step. This is the step of negation, which is you need to change from 1 to 0, from 0 to 1, from 1 to 0. So this is the first step. Second step, you're going to treat all these numbers that you get as unsigned bit number, which is tak adalah positive negative. Then you add this 0, 1, 0 with 1. So you will get 0, 1, 1. So basically this is your two complement, second's complement. So this is the step on negations for your second complement. So this is the example for you to use the negations under your two's complement or second complement operation. You're going to, this one is your positive 18. Alhamdulillah. So you're going to change it to be first complement, and then you add another one, you get 1. Then it's going to be negative 18 using your second complement. Same goes to here when you have the vice versa. I guess it just similar to what you have learned over here, nothing much. Then we will move to addition. You can see over here, addition. This one also I already share with all of you related to this table. This is just your recap. This one is basically you already learned if 0 plus 0, what is the answer, the sum, and then the carry. 0 plus 1, your sum will be 1, your carry will be 0. 1 plus 0 will be 1 as your sum and carry will be 0. 1 plus 1 will be sum 0 and carry 1. So this table, as I mentioned previously, is very important for you. Although, yeah, this is mathematical problem, but when you are
12 hours.
when you are dealing with your binary additions, of course, it's sometimes make you confused because normally you say, okay, 1 plus 1 is 2. Then suddenly it's going to be 1, 0. Basically, 1, 0, this one is your sum, this one is your carry. You can see that this is to the power of 1, 0 to the power of 1. So 1 times 2, you get 2. This one 0 plus 1, you get 0. That's why in your decimal, this one in your binary, base 2, you convert it, then you get 2 in your decimal. So that's why 1 plus 1, you get 10 in binary. And in decimal, it will be 2. So this one is just recap. I hope that you still remember, you dah belajar dekat digital logic as well. So over here, you can try the example of adding two complement. Basically, in two complement, there is no problem. When it's going to be a problem when you did not change all the numbers to two complements, then you're going to get overflow. So over here, you can see the example over here. If let's say you have similar, right? Go back to your previous slide over here on the detecting overflow. If let's say your discharge is similar, then you have no overflow. When it's different, you have the overflow. Later on, you will see also a different situation. So, okay. So this one, there is no overflow, then the answer is correct. Same goes to here. There is no carry at all. Of course, it's going to be correct. And this one, you're going to be discharged. So basically, you get 0, 0, 0, 0. So it's 0. So over here, your carry will be what? You will be 1 similar. Then you will get -5. Basically, over here, you can see this one is 4. No, this one is 1, 2, 2 plus 1, 3. This one is 4. Okay, this one is your second complement. That's why you cannot directly convert it. Sorry. So you get this is -5 in your second complement. Try convert it back to the decimal number. Then you will get -5. Over here, positive, no need to change it to your two's complement. It is direct because it is positive number for all. Then you're going to have example of overflow. So this is the overflow condition. When it's happened, you can see over here, you have plus number, although you have positive number, but your answer over here showing that it is a negative number. So it's going to be overflow. Another example over here is when you have this one, this is your sign. The sign is not here, okay? The sign, if let's say you have 4-bit number, the most sign bit, this is your answer for your sign. So it is positive. Suppose you get negative. So you are assuming it as a overflow happen. So please try to do the example and you will see basically, oh, this is how it happened. And for the answer, please try to convert back to decimal because this one is already converted it directly from the two's complement. See? Two's complement. Next, we have our subtraction. Our subtraction is easily handled with the following rules. So you need to remember the rules. If you have negative or you have subtract number, please tag the two complement negation. Use to complement of the subheading and add it to this one is the one that under negation. So please do under choose complement for your subtraction, and then you will be change it into adding process. So you're going to see this one, basically you have m number and then you minus it with s, let's say. So basically it's going to be m plus. This one I mentioned is going to be adding. Then this is minus s, then you are using second complement. So if let's say I give you example, you have 1010, I give you decimal first. 2 tolak 1, let's say. So you're going to change it to be 2 plus minus 1. This minus 1, you will change it and do the representation using second or two's complement. So basically, you're just going to add. So this is the example. So you are having 2 over here. You need to minus 7. Okay, this is the question for this example. Then you're going to change it to be 2 plus minus 7. Okay, 2 plus minus 7. First, you're going to change your 2. 2, you will get 0, 0, 1, 0. Of course, because this is positive number, no need to change anything after that. For negative number, you can see that you have basically 1, 1, 1, 0. This one is what? This one is 7 in decimal positive, isn't it? So, second step, you're going to change it into, if let's say, the first step, you're going to change it. If it's 1, it's going to be 0. 1 is going to be 0. 1 is going to be 0. 0 is going to be 1. So, this is your first complement. 1 complement. Then, second complement, you add 1. You get 1, 0, 0, 1. So this is your second complement. See? From 7. So your second complement is your negative numbers for your positive value 7. So positive value of 7, you get 0, 1, 1, 1. So you perlu ada negative. So you're going to change it and subtract it to be 2's complement. So you dapat 1001 and you're going to change it into the adding. Isn't it? Adding over here. So that's why over here it's add. This is represent as negative 7 already. So just plus it, you're going to get 1011. So 1011, if you direct convert it to your decimal, you're going to get different from negative 5. So that's why you're going to convert back. If you want to check this is whether it is minus 5 or not, you're going to check back. You will get 1010, and then you get 100. 10. So this one is 4, this one is 1. 4 plus 1, you get 5 positive. This one I change it back. Okay, so show you one by one. From here, this is my second complement. So I nak jadikan balik dia dekat decimal kan. So I'm going to minus 1. Minus 1 lah sebab tadi you add 1 kan. You dapat 1010. And then you change. This one is your first complement. Then you change it 0101. Sebab you tukar 0 kepada 1, 1 kepada 0. Then you get over here, this one is your decimal binary number. You tukar kepada decimal, you going to get 5 in decimal. But of course, you're going to know that this one is second complement. That's why you get minus 5 as the answer. just to see the decimal value, and this is the sign. So this is very simple, and same goes to here. The example, this one is already second complement. When you get second complement, you just add. So over here, it's already mentioned if you have carry, you need to discharge. For the second complement situation, mana ada dalam our class, previous class. Okay, this one. See, discharge carry for second complement, you need to discharge. So please remember back, kalau first complement, your discharge will be carry to next. Wait, someone want to join? We see who is this lucky person. Oh, ask for. Why he's coming late today? Okay, we continue. Oops. Okay, we continue back. So please make sure you remember also what we already learned in our previous class last week. So this one we already covered. Suppose you understand. So if you don't understand, please try to do it many times, the exercise. Plus, please try to find also another resources on the exercise. So same goes to here. You can see that both of these already second complement. So there is no problem at all, and your discharge, you will just discharge and try to convert it from second complement plus. Please try to convert it back and check whether you get this number or not. So this one is very simple because it is positive number, nothing's much. And here you can see there is a situation when you did not use the second complement, you get overflow. Where? Okay, this one. So over here you get overflow. Why? You can see over here. Okay, this one is direct positive number. You can see you have overflow. 1 plus 1, 0, 1. 1 plus 1 plus 1, you get 1, 1. 1 plus 1 plus 1, you get 1. And then over here is 1. So this is, you go back again. Banyak kena pusing-pusing balik. As long as you remember, so you can see there is two rules to be, where is it? Okay, overflow will happen if let's say you add two positive number but tiba-tiba your result is negative. So it's going to be overflow. Mana dia balik? Okay, over here. So you can see this is negative. This is your sign. Numbers over here, suppose it's to be have to be 0, but it is 1, so it's going to be set as overflow. Dekat atas ni, the example yang betul ni, over here, the correct one, you can see there is no overflow because it is a positive. Wait, someone is texting. It's not really good online. Wait. Sorry, doctor, my... Okay, yeah, if let's say the voice or the internet connection is not good, this class is under recording. So later on, I will share also in our e-learning, and you can check it to your YouTube. So you can play and rewind it back. Where is my slide? So over here, we have, okay. So another one, you can see over here, you have, basically this is your sign number and this is already overflow. You nak dapatkan negative, right? But your negative sign is dah terlebih daripada your punya bit. you are using 4-bit over here, so it's going to be overflow also. Try to take a look different also example. So that's on our subtraction. So another one, subtraction can be done directly also. This is the tables, lain sikit daripada our addition table. Saya patah-patah balik, jangan pening if the internet slow is okay. I already record. Later on you can just go back and check back the video in our YouTube. Okay, this one. You can see 0, 0 you get 0, 0, 1 you get 1, 1, 0 you get 1, and then 1, 1 you get 0. And borrow 1 from the next most significant bits. Nanti you akan tengok benda ni. So this is the example. Because this one, dia kata subtraction can be done directly. Tadi kita belajar using first complement. Kalau first complement is going to be adding, tambah. Tapi kita akan guna direct, which is we direct convert this number 37 and this is 17. So you can tengok this one, I selalu kena kira sebab tak pandai nak direct dia tiba-tiba kan. So this one is 1, 2, 4, 8, 16. So dari sini 16 plus 1 I get 17. So that's why ini adalah 17, ini adalah 37. You kira lah yang kat atas ni. Ataupun you direct je convert using your scientific calculator. So from here you going to minus, deduct or subtract it directly using the magnitude number. So this one is magnitude 37, this one is 17. Then you direct minus or deduct. 1 plus 1 minus 1, you get 0. 0 minus 0, over here you get 0. 1 minus 0, you get 1. 0 minus 0, you get 0. And then 0 minus 1, you get 1. But you need to borrow 1 from your next most significant bits. So dari sini, you tengok kat sini, you minus 0 minus 1, you will get 1. Tapi you kena pinjam sebelah. Then you dapat sini 1. So you nampak dekat sini, dia tak akan jadi kosong. Jangan salah. Contoh you dah pinjam kat sebelah ni kan. You pinjam sebelah, you bawa kat sini 1. Lepas tu you buat 1 minus 1. Tiba-tiba you punya answer jadi kosong. Sebab you dah assume sini adalah 1 minus 1. Tengok ni. Kalau you assume macam ni salah dah. You kena tengok this table, you look into this table. 0 minus 1. 0 minus 1 mesti 1. Tapi then you borrow. You buat macam ni and then this one is you just borrow. So if let's say you buat borrow dulu, you buat 0, you taruh 1. Tapi you buat 1 tolak kosong. You dapat 1. 1 tolak 1, you dapat kosong. So jadi jawapan you dah salah dekat situ. So this step is very important when you have 0 minus 1. Please make sure you follow this table. You punya answer mesti 1, bukan kosong. Not 0. It's going to be 1. Follow this table, but you need to deduct the 1 from your most next significant number. Okay? So please make sure this step, remember that 0 minus 1 is going to be 1. Jangan buat borrow dulu. Don't bila you bawa borrow dekat sini, dia dah jadi 1, tiba-tiba you buat 1 tolak 0, 1 tolak 1, you dapat 0 dekat sini. So your answer will be wrong. So please take note this step. If you have 0 plus 1, you're going to follow this. And then you get answer is 1, just tidak is in front as with 1. With 1, you get 0. So sometimes you ignore je lah yang ini. You just assume you dah pinjam kat sebelah. So then it's not going to be confused. You punya jawapan still 1. So another one example, maybe this one you can try to do. Basically it's similar, but this is at bit. This one 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is similar, which is at bit. It already shows you. But please try to show and do it in second complement. So second complement jadi apa? Jadi tambah. Only you need to change this 37 plus minus 17. Macam mana nak dapat minus 17? Tadi kejap saya tengok 10001. Okay. Your 17 will be 1001. This is base 2, which is represent as 17. So over here you will change, later on you will get 10001. So tengok je lah nombor ni, kadang-kadang sebut pun salah. So dari sini you akan tambah pula to get your second complement. You tambah 1, you get 1110. Then the rest you going to change it followed by your magnitude basically. So over here you will get your second complement. So try to do it, but then you're going to add this 37 with your positive, which is positive is 1, adding your negative 17 second complement. So try to check what is the difference between 8-bit and 16-bit for this one. So after you done this, maybe you can WhatsApp me showing your answer. Is it correct or not, doctor? Whether your answer is correct or your step is correct or not. Jangan buat tiba-tiba you dah yakin, tak apalah. Kalau you yakin, then it's okay. But if you not understand, please ask me. Because I'm going to speed up just to finish cover our chapter 2. As you notice, we need to do our lab next week. So we need to finish our module 2 by today. So this one is not by today, by this week. I guess we have another, okay. Multiplication, you can see over here. Multiplication is a complex operation, whether it's performed hardware or software. Ingat senang, walaupun kita just tekan je dekat calculator tu dah dapat jawapan. But it's basically complex operation. So the simpler problem of multiplications using unsigned integer, and the most common techniques for multiplications of number is second complement representation. Dekat multiplication pun kita akan guna second complement. We're going to apply our second complement although we are using multiplications. Macam mana kita nak darab pula? Selalunya 1 darab 0, 2 darab 0, 3 darab 0, semua akan dapat 0. Macam mana kita nak darab pula dengan lagi-lagi we have only 0101 in our binary. Of course lah kita akan dapat 0 selalunya if we are dealing with 0, right? So kita tengok apa jadi lepas ni. So multiplications of binary members must always use 0 and 1. Of course lah sebab we are dealing with our computations numbering system. Of course, we are only have the binary number. So, dekat sini kita akan ada rules. You dah ada table berapa? 2 dah. Tadi table adding. adding tables, and then subtraction table. Now you have a multiple table. Jangan silap ya, lagi-lagi yang subtraction tadi tu saya dah ingatkan banyak kali. Don't do mistake when you are having 0 minus 1. So 0 minus 1, the answer will be 1. So please remember that. So in multiple, you can see over here, 0 minus 0, it will be 0, 0 minus 1, not minus, multiple, sorry. 0 multiple 1, you get 0. 1 multiple 0, you get 0. 1 multiple 1, you get 1. And there is no carry or borrow bit. Ni dia punya hint kat sini. You tak ada carry, tak ada borrow, semua tak ada. In the multiplications. So we can see over here, consists of operation called multiplications and multiplicants and multiplier, and final result is our product. Kita ada multiplicand and multiplier and also product. You ada dua number and then you dapat answer kat sini. But this one for unsigned integer. Kalau signed integer macam mana pula? So we look one by one. Unsigned integer, you can see over here, multiple the unsigned binary number 1011 by 1101. See over here, dia dah bagi hint macam soalan yang tadi example saya dah bagi tahu tu. Dekat sini you were given the hint which is this is binary number, bukan your first complement, bukan you punya second complement. This one is binary number 1011, 1101. So this is binary number you get 1, 2, 4, 8. So dari sini you akan dapat 8 tambah 2 tambah 1, you dapat 11. Sini you dapat 8 tambah 4, 12 tambah dengan 1. So you dapat 13. See, this one is binary number. Then this one is decimal. So you darab. Operation darab ni still sama. You can see over here 1 multiple 1. Sekejap saya ambil dia punya table kat sebelah supaya you nampak. Okay, saya letak dekat sini. Tak apalah. Okay, macam ni. So kita ada operation 1 multiple with 1. You get 1, 1. You dapat answer you 1. Dan you macam mana? Kalau dalam matematik you akan buat 1 darab 1, 1 darab 1, you akan darab 1 darab 1 darab 1 kan? So sama juga macam matematik biasa. Same operation. So 1 minus multiple 1, you dapat 1. 1 multiple 1 lagi kan, dia macam ni kan matematik. Tak, kalau matematik dah tak tahu dah, aduh mak. So 1 darab 1 you dapat 1 lagi. 0 darab 1, sini you dapat 0. 1 multiple 1 you dapat 1. So you dapatlah 1 baru ni. Ini you baru darab yang sini. Now you darab yang sini pula. 1 darab 0. 1 darab 0 you dapat 0. Apa-apa je nombor yang darab 0 ni you tengok, you akan dapat 0. You dapatlah jawapan 0, 0, 0. Then over here you dapat ada 1 dekat sini, you darabkan dia, you dapat 1, 0, 1, 1, 0, 1, 1. And another 1 over here you dapat 1, 0, 1, 1. Dari sini you dah habis darab dulu. So kalau dalam you punya matematik biasa you akan buat apa? Adding kan? So it's called as partial product. you belum dapat lagi semua, you daripada partial ni you akan tambah. Sini akan tambah, kat sini tak ada apa-apa kan? So dapat 1. Sini pun you dapat 1. Sini dapat 1. Dari sini 1 plus 0 plus 1 plus 1. You tengok balik table tu, you akan dapat 1, 1. Dari sini 1 tambah 0 tambah 0 tambah 1, you dapat 1, 0. 1 plus 1 tambah 0, you dapat 1, 0. Sini you dapat 1, 0 juga. So try to do it. This one is multiple, this one is plus. Sama je. Similar concept with your mathematics. Only the different on the tables rules. Tables rules ni dah memang guna pakai macam tu saja. You just apply it. So you dapat this one under your binary. Oh, because this one is your binary number. You convert je lah balik. Saya tak ada scientific calculator. You convert je balik. Kadang-kadang you guna je online. Online convert, online binary convert to decimal. Banyak, saya pun dah try guna itu je. So you convert, you dapat 142,143 as your answer or the product. So if we ignore the sign bit, the length of multiplications of n bit multiplicants and m bit multiplier is a product that is n plus m bit long. We nampak sini 1, 2, 3, 4 bit. Kalau kita tambah, kita akan dapat bit yang sama. 4 dapat 4 lah. Tapi untuk multiple, 4 bit multiple dengan 4 bit, jawapan kita mesti jadi tambah dekat sini. So kita akan dapat 8. 0, 1, 2, 3, 4, 5, 6, 7. So 8 bit. Itu dia punya hint. Dia bagi tahu berapa panjang long. Kalau you dapat lagi satu carry out tu, you kena tengok pula. Carry out tu dia boleh tambah bawa carry ke atau you ignore ke, discharge ke, later on you will see. Only that over here you want to know that you multiple with 4 bit, you dapat dengan multiple 4 bit, you dapatlah 8. Kalau misalnya you multiple 4 bit dengan 8 bit, you dapatlah berapa? 12 bit. Contoh. Ini dia bagi tahu kat sini dia punya hints. So then, tadi tu you buat unsigned integer. So bila you masuk dalam signed integer, normally signed integer ni dia akan confuse sikit. So that's why under signed integer, you akan kena guna second complement or two's complement. Dekat sini you kena pakai two's complement. See apa dia punya beza. Macam yang example tadi tanya kan. Ini dah memang second complement. Kalau saya lah, kalau diberi question, because dia tak ada bagi tahu kat sini, nampak ni. Yang ini dah memang sasar, dia bagi tahu this is binary number. So you lah yang kena convert dia jadi second complement. So we have seen the addition and subtraction can be performed using two complement notification by treating them as the unsigned integer. Later on, you will see that you're going to apply it in the multiplication. So if the number are considered to be unsigned integer, then we are adding, let's say over here, 9 plus dengan 3 to get 12. Ini adalah example. As second complement integer, we are adding minus 7. This one is minus 7. 7 tambah 2, 3, which is to get minus 4. So this one is minus 4. This is the example you can see over here. 1, 2, 4, 8. So you can see totally this one is not salah ni. Second binary. So suppose 7 1 1 1 0 in binary. So binary ni you akan kena convert dia kan. Dia akan jadi macam ni. Dia convert 0 kepada 1, 1 kepada 0. Then you akan tambah dengan 1. This one is first complement, this one is second complement. You dapatlah 1001. This one is your second complement, you dapat 1001. 4 minus 7. Then you sama juga, you akan dapat 3 kat sini, 3 positif, so tak ada masalah. You akan letak sini saja, you akan dapat y100. This one is dalam adding. So this is the example. So how when it's going to be applied? Unfortunately, it's not just a simple scheme that will work for multiplication. Bukanlah simple-simple macam you buat adding, macam you buat subtraction using two complement. Now when you are applying in the multiplication, so you can see multiple the two complement number binary number of 1011 by 1101. So over here, this one is minus 5. This one is minus 3. You can see over here, when you multiple, you will get whatever basically the flow is similar. Then you will get your product as 1, 1, 1. This one is mathematics. I hope you can try it. 0, 0, 0, 1. So of course you're going to get 4, 4, you get 8 bit. Now you get minus 1, 1, 1, 3 as your answer. Is it correct or not? Because this one supposedly you will get only minus 15. That is why it's not going to work in your multiplications. So this example demonstrates that straightforward multiplication will not work if both multiplicand and multiplier are negative. So kenapa dekat sini you punya jawapan salah? Why over here your answer is wrong? Because you are multiple two negative number. So it's not going to be work for multiplicands and multiplier. So jawapan you akan salah. So regular multiplication clearly yields incorrect result. So solution dia ialah dah ada masalah, so you're going to have a solution. Multiplicand's algorithm. So this algorithm has to be need of speeding up the multiplication process relative to more straightforward approach. So apa dia multiplicand's algorithm ni? So this here you going to come up. So you dah tahu kan, dekat multiplication you cannot directly use the sign integer using second complement. So you dah tahu dia akan ada problem, you're going to get error. It's not going to work. Now the solution for all these cases, you're going to apply multiplicand's algorithm. So later on you will see what is a multiplicand's algorithm and hardware. So multiplicands must cope with overflow because we are frequently wanted 32-bit product as the result of multiplying two 32-bit numbers. So we just assume it to be 32 bits. In the next slide, assume that we are multiplying only positive number, unsigned, and the first versions of highly operated multiplications hardware. So this is the example versions. What is multiplication hardware that available? This is the first versions that available. You can see over here the product register, the ALU, this one is the product shift left, shift right, control test and everything. This one is just the example for you to see. Then you can see that the multiplicand's algorithm using hardware. how it start. First, it's going to be start and then test multiplications, and then what happened. So add multiplicants to the product place, and then same goes to here if it is kosong or zero. If one is going to be add with something like this, and then you will get the flowchart over here. This one is only for the first version. Then if let's say you can see using 4-bit number multiply of 2 decimal and 3 decimal, you will get what? So over here you change it to binary. Same goes to here, you change it to binary. What is multiplicand? MC, and then MP, and then product. So step by step, test multiplier, test. Dia kosong or satu. So if one, it will be then 1 over here, right, equal to 1. So masuk sini. So you will P plus MP. So product you akan tambah dengan MP. Then if kosong, there is no operation. So you direct go to your shift. So this one is only just representations what is happening here. And this is the flow chart. And your shift MC left over here. Shift the multiplicants register left 1 bit. And shift the multipliers register right bit with 1 bit. So all the bits done or not? Then if still, then you repeat again the process until you get 32 repetitions and then finish. So this one is 32 bits. Maximum equal to number of iterations based on 4-bit number system. So this one is what happened. What basically happened if let's say you have this one initial value 0011. This one is 3, right? 2 and 3. So this one is 2. And then this one, of course, the first you get 0 only. So 0, 0, 0. This is decimal, this is decimal. So this one is in binary. So first step, you're going to see that you get 0011. So P plus MC. So what happened? MC over here, you will add. So you will get your product. This one 0011. This one your MC 0000 0111. So over here you can see that you have the 1A. If let's say P equal P plus MC, then you're going to go to, see, I need to refer back to the flowchart. So you're going to add multiplicand product and place the result to the product register. Please try to do it in different paper. Then you can see it clearly because I need to refer to the flowchart and then refer to this back. Please try to do it first. Then you can be more understanding in what happened here. If you didn't understand, we will discuss it later on back. Maybe I will do it separately or maybe separate video just for this example. So there is also another exercise too. 2.2, you need to come out with this table similar. 4-bit binary arithmetic, you have 5 and 4. So using first version, highly optimized multiplication hardware. So this one. So what is MP over here? 5 dengan 4. So you need to have 5 and 4. 4 dekat mana? And 5 kat mana? So produk mula-mula you dapat berapa? So please try to do this exercise, and basically it's just a similar with this. Try to finish the table, then you can see the flow for the first versions of multiplication hardware. So aside from this, multiplier MP must always in positive number. This is another condition limitation. So you need to have positive number only. And then do an additive inverse to the multiplicand, which is MC, and the MP. So you can see over here you have MC and you have the MP. So you minus it, multiple it. So you're going to get minus MC multiple MP, because it's already mentions that MP must be always positive. That's why you will change it to the negative, you're going to change to the multiplicand. So let's say the question like this. You get 7 multiple minus 5. So you're going to change it like this. If let's say you have over here, of course, minus the times minus, you get positive for both. So you need to notice that MP will always be positive number. Is okay? So if let's say this one is also example, quite simple, you just need to change it. So all of this is more to mathematical, and try to come up with this table also. This one is basically similar. You need to have the table. So it's already give you the initial value compared to the 2.2. 2.2 you need to come out. Kat sini 4 ke? Kat sini 5 ke? So what is the product for the initial value? For the 2.3 is already give you the initial value. So easy for you to try to finish the table. So there is another exercise 2.4 also. And I will touch until division just to speed up, because I guess what else we need to cover? 63. So tomorrow another half slide also I need to finish, just to finish our chapter 2. Then next week we're going to move to chapter 3 and our lab 1. So over here under division, you can see that normally in mathematics it's very easy to just divide it using calculator, but it's more complex than multiplications based on the general scheme. Wait, Then over here, an operation is even less frequent and even more quickly. So in even operator, the operational opportunity to perform mathematical invalid operations by dividing with 0. So if you have this, it's going to be invalid operations. Two operands calling, sama juga dalam multiplication, you have the dividends and divisor, and your answer kalau dalam multiplication you have product, but the result over here is quotients with the second result called the remainder. So you have the remainder ni dah biasa dah. You have all reminder kalau you have the division. So it's already play around with your mathematicals last time. So I think it's not hard, just to apply the methods. That's the purpose. So another way to express the relationship between components. So you have the dividends equal to quotients multiple with divisor plus remainder. So this is basically what happened in your divisions. So you ada division basically, but what happened inside is basically like the adding process and also multiples. So where the remainder is smaller than divisor. So infrequently program use the divide instruction just to get the remainder, ignoring the quotients. So you will see also there is two similar to what our previous, which is unsigned and signed integer. So for unsigned, it's basically just similar to your divisions process in your mathematicals. So over here, the following figure shows an example of long divisions. Unsigned binary integer 147 divide with 11. So I call it 11 because this is a decimal number. So you divide it using your binary. Change it into binary, you will get like this. And this one is your binary for 13. So you're going to divide it, then you go it by one. Uh, there is no given table, okay. So you will get 1011. Ni macam matematik, kalau you bahagi dengan 1011. What answer you will get? Sampai sini you will get kosong juga because it's only 1001, right? So daripada sini you get 0. What is the reminder? 0. What is the reminder? But this one is calling as the partial reminder. And overall over here is going to be full reminder. Wait, someone is okay. Where is chat? Okay, I continue back. Okay, then over here you have the partial reminder. Basically, it's similar to your divisions in mathematics until you get full reminder. Then you get the quotient and also reminder after you done the divisions. And the problem will come in when you have the signed integer, which is you're going to basically use the second or two's complement to make both dividends and divisor positive and perform division. Why you need this? This is the objective. Make the sign of the remainder match with a divisions, no matter what sign of the divisor and also quotient. So you need to make it similar. So this is the rule. If let's say I give you the example over here, positive 7 divide with positive 2. So you're going to see, let's say this one is positive and positive is not going to be two troublesome. So if you have positive and negative, you get negative for the quotients and remainder is positive. And you have minus 7, your quotient will be negative and your remainder will be negative. And minus 7 you and also minus 2 you get positive and negative for remainder. So negates that quotients if difference and divisor were of opposite sign. So you can see over here, you need to negate the quotients. Quotient is over here, which is basically 3. If the divans and the divisor were of opposite sign. Kalau dia berlainan signs, positif, negatif, lagi satu yang ini. Positif, negatif. You kena buat this as negative. This is the one that is mentioned over here. Sini dengan sini you tengok lain, so you going to make this as negative. Selalu you dapat nilai sahaja kan, so you going to make it negative. And same goes to here, negative, positive, your quotient you will make it as a negative. Negate the quotients if your dividends and divisor were the opposite signs. So this is what is the meaning by these notes. So make the sign of reminder. This one is reminder. Mesh to dividend. So dividend yang dekat sini, you kena mesh kan dengan yang ini. So there is two rules that you need to remember. First is you need to make the quotients all be negative if you ada two different operations. Another one is reminder, you will make it to be similar with your dividend. Make the dividend and divisor positive perform. And this one is the one how you're going to perform is sign the integer using to complement. But the most important is these two on how you come up with these rules of tables. So the division algorithm and hardware, same goes to multiplications. You have also divisions algorithm and hardware. In this, of course, we're going to use 0, 1, 0, 1 again. And then the next slide after this, you're going to assume that both dividend and divisor are positive number. So that's why hence quotation and reminder are non-negative. So kita nak kena assume dia because we going to use our second complement later on. So hint illustrations of algorithm need to be moved the divisor to the right, one left. I think this one is quite similar with your multiplication, only that this one is 60 bits, similar I guess. This one is 32 bits. We're going to divide the 32 bits. So please take note, what is the difference under division hardware and also the multiplication hardware. Please check it, the timing diagram for both of it, and please check what is the difference, whether it is shift right or shift left. And about the flow chart, you can see that they are totally different in the flow chart about the reminder, of course, but the flow is going to repeat and it's only will be looking up until here, but for the multiplication it's already start at the first task and it's going to repeat 33. Why is 33? And if you check back over here, it's only repeat 32. So please try to do it and justify why there is a difference between multiplications and also divisions. Jauhnya. Wait dah terlepas. So until over, where is it? Okay, so over here, why it should be 33? Why it's not 32? So please try to justify it to me later on in our next class tomorrow. And try to find the biggest differentiation between timing diagram for multiplication and also divisions. So try to do the example also, and I'm going to stop until here. And this floating point and floating point algorithm, we're going to cover it tomorrow and we're going to finish it until summarizations. And if let's say you still did not understand, before you ask me, please try to do it and come up with your own table. It's 13 hours. So I guess we can stop until here only. I need to change my timetable basically in Wednesday, I have class until 5 p.m. After your class, I have another COA class for MJIT. So today is scheduled on the Wednesday class. I have class from 8 until 5, non-stop. So I hope if let's say you did not understand, please ask me or direct WhatsApp me, and we're going to discuss it in class with all the friends. Okay. So whoever come late, please make sure that you already also. Arif Sofian, kenapa you angkat tangan? Hilang dah dia. Tadi kot, waktu yang first tadi. So if let's say you still did not scan your QR code, please try to scan it because I think we already tag and start taking the attendance starting by this week. There is also extended add and drop subject, right? But still, I guess all of you for first year student didn't do and normally not do the adding and drop subject. So starting this week, we already looked into your attendance. So you need to occupy 80% until the hour end week 13. Is it okay? So next week we will start dividing your group. I need to follow others lecturer. Wait, I check about the group. Okay, the group project is going to be 4 students in one group. Lab, we're going to do it 2%. So you're not going to do it individual. So again, I repeat, for lab, it's going to be 2 students in one group. And for project, it's going to be 4 students in one group. So I'm going to try to do the group because they already give us the form to grouping the group and they're going to share with all of us, all the lecture. So I guess by next week, we will form the group and you're going to follow the group until the end of this subject, until the end of this semester. So thank you all for your participation and meet again tomorrow. Bye bye.
Thank you, Dokter.
Okay.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor. Thank you for
Doctor,
Yes.
can you send today's recording?
Wait. I hear the fan sounds clear more than your voice.
Sorry. So, Doctor,
Okay, again.
send today's recording afterward.
Again.
Can you send today's recording afterward? I want to watch the recording.
Oh, okay. Because I'm not stopping yet. Okay, I will